Welcome everybody. My name is Petrell. I'm a developer here at OpenForge. Today we're going to be talking about some full-stack TypeScript, and hope you enjoy the talk. So, without further ado, let's begin. Like I said, my name is Petrell. I started programming when I was about 10 years old. Started with game development, and I've moved forward into web development by going to a coding bootcamp. And now I work here at OpenForge as a mobile developer, like I said. I like compiled languages, and compiled languages have a lot of advantages. So tooling, auto-completion, type checking, all that stuff comes with TypeScript. And that's why it's great. It also has a great community, as well as it works with JavaScript. So, compiles down with JavaScript, I should say. So, let's get into the meat of it. So here's a picture of kind of one full-stack architecture. You can see that there's some AWS Lambda here, as well as some GraphQL. We're going to be talking about some of those technologies today, as well as Nest.js and some of the other backends. Here's the database MongoDB down here at the bottom. But today we're going to be connecting to MySQL. But using TypeORM, we can switch between those two without a problem. So hopefully I can talk about this architecture without making your brain explode like this kid over here is in the picture. So I had a few kind of goals when I was working on this project. I wanted to make a full stack application that that's flexible, is fast, and I could also expand. So I wanted to build something that was a skeleton that could be used for my portfolio website or for any website that I might need in the future. For scalability and for cost sake, I decided to go with Google Cloud Functions. Originally, I had tried to work with serverless technology, which is a framework which allows you to work with or be cloud agnostic. So you can use the same code and deploy to the different cloud providers with that same code. It turned out that some of that vendor lock-in was actually a better idea. Having some of the servers, having the SQL server close to where the server that's actually running the backend code is, tends to be a lot faster. So like I said, I wanted something fast. I wanted something that can scale. Google Cloud Functions and AWS Lambda allow you to do that. So they auto-scale on their own. If you get more requests to that particular server, or in this case serverless server, then there will be more in that particular region, or there will be more servers in that particular region spun up to handle those requests automatically. So I wanted it to be easy. I wanted to do something that I could do in a few weeks. And I did that successfully for the most part. So here's what AWS Lambda says: you pay only for the compute time you consume. And that was the attractive thing for me, is that I wanted to be able to make a portfolio site or another small site that could be expandable, but also wouldn't cost me that much. And the old way of doing things, using software or a platform as a service, where the vendor controls some of the things, like the vendor controls the operating system, vendor might control the next level up. Function as a service allows there to be more control from the developer side of things, or less control, or less need to understand DevOps to be able to deploy this. So a very quick development, and then building and then deploy process for working with Cloud Functions. Talking a little bit about Node.js, so decided to use Node.js in the back end, mostly because it has these fast cold starts. So very small runtime that JavaScript runs in. That's very different from a lot of the other programming languages that are out there that are available on Cloud Functions and AWS Lambda. They both do have different choices, but they both run Node.js. Node.js has that fast cold start, like I said, because of the low runtime. It has a very low memory footprint. Like I said, compared to something like Java or C# with a large virtual machine, or not a large runtime which it needs to run inside, like JVM, the Java virtual machine. As well as, so I also, once again, I went with that vendor lock-in where we choose Google as the SQL provider, so Cloud SQL. I also wanted it to be flexible to work with not only SQL, but like I said, MongoDB or NoSQL databases. So I also wanted it to not only work with the SQL databases for fast joins, queries that we're used to for those that have worked with SQL for a while, but also using Firebase's real-time database to handle real-time data over time. And so if there was a messaging system, or let's say there was a messaging system where you have multiple users sending messages to a particular channel, you want all of those users to be to be updated when there is a change to anything in that channel. So one person puts up a message, and the other person should get that message on that same channel pretty much instantaneously. That's a little bit harder to do with SQL, and so I've integrated with both the real-time database that Firebase provides as well as the fast transactional queries that SQL provides. I also made a decision to use Apollo Angular, so using Angular in the front end with Angular Universal. Angular Universal is a server-side rendered version of Angular itself. It's a little bit less mature than Next and Nuxt, which Vue and React have server-side rendering for. The cool thing about Apollo Angular is that it's very batteries included. You have optimistic queries, which means if you, let's say you're liking a post and you're clicking that like button, it will automatically update the front-end UI while sending that request to the back-end. Once that request returns to the front-end, then it will, if it fails, then it will revert back to the older version. If it's successful, then the UI will remain the same, right? So it'll make those UI kind of interactions with the user a lot quicker. So like I said, something that's fast, something that's flexible. There's a few things that I didn't include in this project because it was a shorter project and something small, and that was a baseline or something as a skeleton that I could use for other projects. So you could still integrate with Stackdriver or some sort of logging services. Redis for caching, all of that is completely possible. But like I said, feel free to take the code that I provided in the presentation and continue to add on some of those things. And hopefully you'll be able to ask me some questions at the end of the day. So let's keep moving forward. Okay, so the question is, can you work within the bounds of the requirements? So like I said, my requirements were for the application to be fast and to also cost a low amount. The good thing about Cloud Functions and AWS Lambda is that they are priced per invocation. So you can see this AWS graph or table on the left side where there's a certain memory size. So increasing memory from the top to the bottom of the graph, but you can see that duration decreasing as the memory increases. But there's a somewhat of a fall off right around here where you're increasing the amount of memory, but the amount of price or the duration is not actually decreasing that much. So there is a diminishing returns. You do have to think a little bit as a developer about how much memory size your Cloud Function is going to need to run. Like I said, Node.js has a small runtime, and so that's why it's fast. And it's much faster than some of these other Java and C# that are on the old way of doing things, where a server is up all the time. You can keep these cold starts to a minimum by warming the job or warming the function periodically with some other cron job or something that gets run every 5 to 15 minutes or so to actually keep your function warm. This will actually cost a little bit more, but your function will always will be up more often, which will allow requests to be handled a little bit faster. So what does serverless mean for the front-end folks? So dynamic SSR versus static pre-rendering. There is a difference, and they do have use cases. So the same thing with Cloud Functions versus servers all the time. There are better decisions for different use cases. So for static pre-rendering, here's the actual command that you run to pre-render using Angular Universal. So the highly dynamic pieces can run on the client side, rendered once Angular gets bootstrapped. So the way that static pre-rendering works is that it will run that pre-render, hydrate the data in the HTML before we end up sending that HTML back down to the client. If you have a smaller amount of times that you need to change the actual data, this is also a good idea. So if all you're doing is changing like one JSON file every 3 months, or you're changing a few things on your resume like once every every 6 months, and you won't have to worry about this fast process. So the static pre-rendering is better for that lower entry where you're making changes to the repo less often. Whereas dynamic server-side rendering is better when you have something like a blog or something that changes relatively often, and you need to populate that data often and reliably. And you also need SEO. So static pre-rendering and dynamic server-side rendering both give you improved SEO compared to just client-side render apps. However, like I said, there's different use cases depending on what your requirements are for the business. So here's somewhat of a little diagram showing how in server-side rendering, the HTML gets sent immediately to the browser, so you can view it a little earlier. But then the JS gets downloaded, the entirety of the Angular application gets sent serialized through JSON all the way down to the client side, and that's when the page is interactable. Whereas client-side rendering, in contrast, you send that the response to the browser, which then it downloads the JS, and then it becomes viewable and interactable at the same time. So the difference here being is that your users are going to be able to see what's on the page quicker, and your SEO is going to be better when you use server-side rendering. But however, you will be able to interact with that page way later than if you were to use client-side rendering. It really depends on the connection, and like I said, there's differences between server-side rendering and client-side rendering that we've already discussed that make them better in certain use cases. So here's an example of such. New York Times is a pretty well-known website. We're using Lighthouse here to show some of the benchmark results. You can see that the first contentful paint is 2.3 seconds, despite the fact this is a very large site. And the time to interactive is 38 seconds. And so the priority for New York Times is to get all of their information indexed so that Google can search through that really quickly. At the same time, they don't really care too much about the time to interactive because it's mostly the information on the screen that needs to be read. So once again, it depends on the use case. So here's an example of some of the things that I looked up and the part of the application that I produced. This is some front-end Angular universal code. You can see Angular Core is imported at the top here, but Angular Platform Browser is the actual package that Angular Universal uses. And all I'm doing here is passing a data object on the class itself, on the class instance itself, and on initialization, I'm setting these meta tags. So OG stands for Open Graph, which is how whenever you share something to social media, that image is brought in from the metadata that's present on that HTML on the page. And so what server-side rendering allows you to do is to set this metadata before the index.html gets sent back to, in particular, the scraping server, so Google scraping server, so that it can find whether or not your page matches with whatever the user is searching on Google. This with server transition, part of the browser module that we're importing here into the app module. This happens to be the app module for this particular application. The with server transition method says that, hey, once we send the serialized version of Angular down to the client side, replace it and use Angular to actually run whatever you need, whether that be authentication, any of those larger kind of pieces, login authentication that would normally be harder to do on the server side. You can do it on the client side once the Angular application gets brought down. Let's move a little bit further to the back. Like I said, Apollo is great. It gives you that optimistic UI. It also gives us code generation. And so when we create our schemas for GraphQL on the back end, we can generate the TypeScript that our front-end Angular code will be using. It also gives us caching and state management out of the box, so you don't have to use anything like Redux or Vux or any of those other, state management libraries, MobX, etc. It has some caching, so you don't have to make round trips to the server. And that's another kind of advantage of using GraphQL is that we're going to be making as few round trips to the server as possible. And in addition to that, we're going to be having cloud functions running, so it's going to only run when those backend calls get made. And the backend code has the GraphQL that actually can make multiple requests to other servers. So the great thing about this is that the server that lives in the cloud that's running this cloud function in GraphQL can make all the requests to the other servers instead of your client. So GraphQL makes all these requests, and then it will consolidate the information and give only what you need to the client side. So here's that example that I was talking about here about increasing the number of votes. We provide an optimistic response and tell GraphQL what to do, or tell Apollo what to do on the client side before that request comes back. So what to do, what it should expect to change in the UI. That's what the optimistic response is for. So here's kind of what I was talking about there. GraphQL is that center of all the data. You can bring in data from multiple different tables, multiple different APIs even, multiple other RESTful APIs, and of course that internet connection in the cloud on Google's or Amazon servers are going to be way faster than your client's browser, or your client's browser or app or whatever it is that your client side is. So that's kind of an advantage there. It's all about speed in this case. So kind of a little bit about GraphQL. There's type definitions, there's schemas, resolvers, and there's also models. So these schemas kind of define the shape of your code. The type definitions are great, so we use type GraphQL. Nest.js actually has an integration with GraphQL. And once again, this is a smaller project, so I wanted to find things that are easy to integrate together. TypeORM also integrated very nicely. We're going to be connecting to that Cloud SQL backend through GraphQL. And then eventually putting that data inside of Firebase and logging in that way. And we'll see an example of that soon. And we'll also see an example of more of these decorators that Nest.js kind of has. So Nest.js is kind of like the backend part of things. Let me go back a little bit here. This is the actual logo for Nest.js. It is a backend framework that allows you to work with very similar code to what Angular looks like in the front end. So you have modules. You have, for those that are familiar with Angular, you have modules. You have services. You have decorators almost all over the place, and we'll see some examples of that. And I wanted something that was very streamlined. Streamlined, fast, like I said, easy to pick up. Which is why I created this project. So here's kind of like an example of how the backend request looks. So once the server receives the request from the front end and sent out by the Apollo client, Nest will take that request, pass it to GraphQL to say resolve this for me, where the server then takes that GraphQL resolver and looks up that query, resolves as necessary, and then it wraps that returning data before it gets returned to the client. It wraps it in this data field. That's just how GraphQL works. And then our Nest and Cloud functions spit it down. So Nest gets run as soon as we run the Cloud function. The Cloud function is going to spin up. Nest starts up, then GraphQL, and then GraphQL hits that Cloud SQL instance in the cloud, which then will return that data back and then spin down that function. So here's some examples of what the GraphQL resolvers in my application are using. Simple example using authors. So given a display name, an email, and a password, we actually call the Firebase auth flow, so admin.auth, a create user. So pulling directly from Firebase admin, using the admin auth on the back end to create that user. And then once that user gets created, then we send it to the author service. And the author service here sends, first it gets the repo. So if anybody's ever heard of Laravel or some of these other larger MVC frameworks using PHP, this has all of those same ideas, as well as Angular, right? Singletons, a lot of these larger programming ideas, as well as repository patterns. So a lot of programming patterns that are good to use. You can see the constructor, the class syntax, and decorators here as well. So Nest.js is really awesome to use with Angular. So first we get the repo. Like I said, you get that repository, which accesses the author repository, which we can call, in the case of create, we end up calling just create, right? So TypeORM as an object relational mapper allows us to call create, and then we can switch between MySQL, MongoDB, any of those, and it will do the corresponding operation in that database that matches. So an ORM in this case allows us to be a little bit more flexible. So it will save that new author, and then it will return it back to our GraphQL resolver, and then that's when we end up getting the data back to the front end. Here's a little bit of information about the database connection. So in this case, you can see I'm connecting to MySQL on port 3306, which is standard. And then in production, we actually have a socket path. So a socket connection is actually created between the Cloud Functions server and the Cloud SQL in the cloud. So there's a small time where that actual connection is made, and that's what we use in production. In non-production, where we just use a Cloud SQL proxy in order to connect. So that might be a little bit rough when you're trying to come and set this up. Understand that there's a few things you'll have to set up, like the security between your Google server or your serverless server and the Cloud SQL database, or whatever other database you decide to use. These requests do have to get sent across the wire, and if they don't have permission to do so, you might run into some issues. So here you can see the entry point of the application. So this is kind of like index.js, what runs when we send it up to Cloud Functions. And then on the request to API here, that's where we actually have access to that GraphQL instance. And we also have a test user create here, so we can actually use Google's other features to do other things, maybe print things out or send things back down to the user when a new user gets created. So this kind of has more to do with the real-time features and kind of an example of how you can integrate when that user gets created. You can do things immediately, push that down, change any data in the backend, which then can respond to, which then your Firebase database can respond in the front end. So let's do a little quick demo. Hopefully we have enough time here. I'm going to push up, deploy this. So this is the backend first, so I'm going to deploy the backend first. And while we're deploying that, we can look at a little bit of the code here. So note that, like I said, there's a Cloud SQL proxy here that actually allows us to connect to Cloud SQL without having to actually have any credentials. There's a JSON file, which with my GCP credentials. So if you end up using Google Cloud Functions, you're going to need credentials. You can download that JSON file. And there's also entities. So the entities represent, we're going to go to the author entity here quickly. You can see there's a couple of decorators here, one from TypeORM and one from TypeORM and one from TypeGraphQL. So this allows us to automatically generate those, generate the types based on the schema. And so I'm actually using multiple here. You can see field from TypeGraphQL and column from TypeORM. So there's multiple decorators on each. And the cool thing about decorators is that they apply top to bottom and they work in series. So you can apply multiple. Decorators are sort of, they're used heavily in Angular. And the idea is of a decorator, it's not actually a feature of Angular. It's a feature of JavaScript, ES7 JavaScript in particular. So column and field are these decorators that add this functionality basically to these fields that exist on this class instance. So like I said, what this allows us to do is define what that SQL database looks like in the backend, and TypeORM will actually synchronize based on like you saw in the presentation. TypeORM has a synchronized kind of field that allows us to do that. Let's see if we are actually deployed here. So all it does is it will run a pre-deployed script, which will destroy the disk folder, which contains all of our code, and then we run the TypeScript compiler, which will end up compiling that code down to JavaScript, and then we point to that tsconfig build.json to actually set up the config, which actually allows it to work. So here's kind of a little look at that. Some of these things are a little bit different than how you would normally do them if you were just running them locally. Having things work in Cloud Functions, so you have Firebase.json that defines where the source is, and the source is this server folder here. And then inside of the server folder, we have the actual package.json, let's find it. And this points to dist index.js. So we're compiling to that folder where Google Cloud Functions will start running, where we actually hook in to the entry point of the app that I showed there. So it looks like we have successfully updated the API. Let's send a request. So let's send a request here. So first let's post. Let's say there's a parks. And we use that simply simple.com. And let's get a password. So we're passing these variables in, and the way that you tell GraphQL to do that when you're using, you can use JSON or you can use GraphQL. But here I'm going to send it just using JSON. So you have the mutations. You have the mutation that we're actually going to be doing, which is add author, and we're passing in a few things here: the email, the display name, and the password. And then down here, we're actually going to have the display name, the ID, the email, the password, and the refresh token come back from that query. So let's do that real quick. Hopefully it runs. We're hitting that endpoint that we just set up, that we just started running. So here we get rows of parts back here. It tells us what the email is and the refresh token, which is wonderful. If we try to do that again, GraphQL should send us an error here telling us email address is already in use, which is great. let's see if we can get all the authors now. So we can also change the fields. So let's get all the authors first. So this is a very similar kind of thing. All we're doing is sending it as a query parameter or a route parameter. That's our query parameter, where we're actually trying to get the display name, the email, and a refresh token of all these authors. This is another resolver here. This is a query resolver. And if we want to, so you can see some of this, you can see our new Rosa Parks here. There's only one of them, right? There's no duplication here. This still is using a SQL database as its core source of knowledge. So if we don't want to get this refresh token, let's say, all we gotta do is get rid of this. And all of a sudden we only have the display name and email. So the power of GraphQL is really not having to worry about performance. You don't have to worry about, I only need this part, but I'm getting overfetched data, right? You're getting only the amount of data that you need. And you can see that this is 1.03 kilobytes. And if we try to do this again, this is a little bit bigger, right? So it's all about getting the smallest amount of data back as quickly as possible. And this still is pretty quick, 236 milliseconds. That's kind of a bit of the demo. There is a front-end piece as well, but it was a little bit difficult to actually integrate with Angular Firebase or Firebase with Angular Universal because of server-side rendering. So once I update that, I'll definitely be updating this repo to include the front-end piece as well. Although we can deploy that quickly as well. There's no problem with that. There's a repo for that as well. So I will be updating this. Right now, these point to the same project, but they're not actually in the same folder. So it's actually going to ask us to whether or not we want to overwrite before deploying these functions. So let that run and we kind of wrap up here. So here's some of kind of the credits. Like I said, there's all these articles that I looked through to the performance graph that I showed earlier. Some of the ideas that I talked about were all included in these articles. Special shout out to Jeff Delaney, Fireship fame, and Ben Alwad as well, who helped me get through some of the GraphQL pieces. So I took pieces from both of these projects to get started, updated a lot of the dependencies, and then kind of made it work for my use case. So here's kind of a link to the repo of the backend, at least until I update that front end portion. I'm Petrell on LinkedIn, and you're able to access my GitHub there as well. So today we went over Full-Stack TypeScript. We created a full-stack application using Google Cloud Functions in the backend and Nest, as well as Angular Universal on the front end. Hope you enjoyed it. I didn't include some of logging and some of the error handling, so you can add on those pieces if you'd like. But if you liked it, subscribe and hit that like button.